Good morning. My name is Vishnuvardhan. I am from Tribly first year. My roll number is 21951 capital A0246. Today my tech talk topic is role of IEEE in quantum computing. We know the full form of IEEE. IEEE stands for Institute of Electrical and Electronic Engineering. Let's see what are the topics we are going to study today. The topics are: what is quantum computer? What is quantum computing? Requirements of quantum computing. How quantum computer works. Qubit. Quantum properties used. Advantages and disadvantages and its applications. So let's see what is quantum computer. A quantum computer is a machine that performs calculations based on the law of quantum mechanics, which is the behavior of particles at the subatomic level. A quantum is the smallest possible discrete unit of any physical properties. Quantum computing. Computation depends on principle of quantum theory. What is quantum computing? Quantum computing is the area of study focused on developing computer technology based on the principle of quantum theory, which explain the nature and behavior of energy and matter on the quantum level. Computers based on this theory are so smaller and faster than digital computers. Calculation based on laws of quantum mechanics uses quantum mechanical phenomena to perform operations on data. So by using quantum computing, these quantum computing computers will work faster than digital computers. It is far better than digital computers. Rather using digital computers, if we invent quantum computers, it is better and it is faster too for anything which will be helpful in our future. But creating a quantum computing is very risk and it is also expensive. So many of have not didn't try to invent that. Let's see what are the requirements of quantum computing. Requirement of faster technology. Requirement of smaller calculating devices. National security require advanced supercomputer. Require advanced technology for civilian, business, trade, environmental. So to invent that we need lot of requirement. Let's see how quantum computer works. In a 3-bit register of a classical computer, one of the 8 numbers can be stored, but in a quantum register, all 8 numbers can be stored in one register at the same time and operated on simultaneously. So it is much more faster than digital computer. So in a 3-bit register, only one of the 8 numbers can be stored, but in quantum register, all 8 numbers can be stored. This is a disadvantage and advantage also. Qubits. Qubits can represent numerical possible combinations of 1 and 0 at the same time. This ability to simultaneously be in multiple states is called superposition. To put qubits into superposition, researchers multiplicate them using precious lasers or microwave beams. We already know how digital computers work. It works in the numeric combination of ones and zeros. So for that, our researchers also using laser lights and microwave beams to make that possible and make superposition. Quantum properties used. There are 3 types of quantum properties used. First one is coherence, second one is entanglement, third one is uncertainty principle. Let's see what are they. Coherence. It's the biggest problem. States that if a coherent interacts with the environment, it falls into a classical state without superposition. So quantum computers to work with superposed states, it has to be completely isolated from the rest of the universe, not observing the state, not measuring it. So coherence is the biggest problem, falls into a classical state without superposition. So quantum computers to work with superposed states, it has to be completely isolated to the universe. So it is the biggest problem to us. Second one, entanglement. Most important property in a quantum information states that two or more particles can be linked, and if linked can change properties of particles changing the linked one. True properties particles can be linked and changed each other without interaction. So third one, uncertainty principle. Quantum systems are so small, it is impossible to measure all properties of a quantum system without disturbing it. As a result, there is no way of accurately predicting all the properties of a particles in a quantum system. So that is, we can't calculate the number of particles in a quantum system. So this is the uncertainty principle telling us about. By inventing quantum computers, there are advantages and also disadvantages to us. Let's see what are the advantages we are having from quantum computing. By using quantum computing, we could produce massive amount of complex data, ability to solve scientific and commercial problems, process data in a much faster speed, capability to convey more accurate answers. More can be computed in less time. They are used to protect secure web pages, encrypted emails, and many other types of data. So when we compare the advantages with digital computer and quantum computer has a good advantages which we can use to process massive amount of complex data at a time. We can solve commercial problems too, and the data process is faster speed when compared to digital computers. But why are we not using quantum computers? Because it also have a disadvantages. So let's see what are the disadvantages of quantum computing. Quantum computings are hard to control quantum particles. It gives lots of heat. It is expensive, difficult to build, not suitable for word processing and email. Problems of it need of a noise-free and cool environment. Complex hardware scheme like superconductor. So by seeing disadvantages, we can understand why we are not using quantum computer, because it is expensive, difficult to build, not suitable for word processing and email, and moreover it is hard to control quantum particles. That's why we are using digital computers rather than quantum computers. We are having both advantages and disadvantages, but when compared to digital computer, quantum computer have more disadvantages. That's why we are still using digital computers rather than quantum computers. And researchers also can't invent quantum computers because of these disadvantages. It is very expensive and difficult to build. And if we want to do, the hardware scheme should be like superconductor, which is very hard to invent. That's why we are still using digital computers. Let's see the applications of quantum computing. Encrypted technology, ultra secure and super dense communication, improved error correction and error detection, cryptography, searching, factorization, encryption problem and quantum computing problem, molecular simulations, simulating. So applications are very nice. Okay, once again let's see what we understood in this first topic. What is quantum computer? We know what is quantum computing. It is a machine that performs calculation based on quantum mechanics, and it is made of particles at the subatomic level. So what is quantum computer? It is computer built through quantum in subatomic level. It is built by particles at the subatomic level, and it has smallest possibility. So what is quantum computing? Quantum computing is the area of study focused on developing computer technology based on the principle of quantum theory. So this is what quantum computing is about. Requirements of quantum, we saw already requirements. It needs faster technology, it needs smaller calculation devices, it require advanced supercomputers. So there are a lot of requirements. And how quantum computer works, it in normally in digital computers it runs with zeros and ones, but in in normal computers one of the 8 numbers can be stored, but in quantum all 8 can be stored. It is the advantage of the quantum computer. And digital computers work with the combination of zeros and ones, but quantum computing have the ability to use both in it, and it is called a superposition. The researchers use to create superposition with lasers or microwave beams. The quantum properties we already read about quantum properties. There are 3 properties. First one is coherence, entanglement, uncertainty principle. Coherence, it is the biggest problem to us. It falls into a classical state without superposition. To work with this, we have to completely isolate the rest of the universe. So it is a big problem. And entanglement, the most important property in quantum information. Two particles can be linked and changed each other without interaction. So this is the advantage with the entanglement. And uncertainty principle. As a result, there is no way of accurately predicting all the properties of particle in quantum system. So this is what uncertainty principle about. Let's see what are the advantages and disadvantages. Advantages is cryptography, searching, encrypted technology, simulating. It could process massive amount of complex data. Process data is very fast when compared with digital computers. But the disadvantages is it is very expensive and it is difficult to build. Lots of heat is generated, and moreover it is hard to control quantum particles. The advantages we have and the disadvantages we can compare with digital computers. Digital computers have more advantages and less disadvantages when compared with quantum computing. That's why we are still using digital computers rather than quantum computing when we have a good advantages with quantum computing. So that's the reason. And nowadays our researchers also planning to build a quantum computing system. So this is my topic is about the role of IEEE in quantum computing. So thank you very much.